Privileged Access Workstations, or PAWs, give administrators a clean, controlled place to perform high-risk tasks. By separating privileged activity from everyday exposure, like phishing, malware, and unsafe browsing, PAWs help protect credentials and make secure administration more predictable. Up to this point, we've built the access foundation: privileged identities, least privilege, zero trust, emergency access, and PAM capabilities like vaulting, rotation, and session monitoring. The key checkpoint is this: those controls protect access, but PAWs protect the endpoint administrators use to access critical systems. If that workstation is compromised, the privileged path is already at risk. A privileged access workstation is a dedicated, hardened device used only for high-risk administrative work. It is not used for email, casual browsing, downloads, or document work. By separating admin activity from normal user activity, a PAW reduces common attack paths and gives privileged users a trusted place to reach domain controllers, servers, cloud consoles, and PAM tools. The reason this separation matters is simple. Privileged credentials should never live on everyday laptops. Standard endpoints are constantly exposed to phishing, malware, risky downloads, and consumer apps. If one of those devices is compromised, attackers should not find admin passwords or active privileged sessions there. Admin actions should happen from a hardened workstation with restricted access, approved tools, and clear monitoring. That reduces attacker options and gives security teams a stronger point of control. A standard workstation is built for productivity. It supports web access, email, collaboration, local files, and a wide range of business apps. A PAW is built for control. That means no casual browsing, no email, limited approved tools, restricted network routes, stronger authentication, hardened settings, and continuous monitoring. The trade-off is convenience versus risk reduction. Because admin credentials can affect critical systems, the PAW needs a much stricter security baseline. Administrative tiering is the core mental model behind PAW design. The workstation you use must match the trust level of the system you manage. Tier 0 is the highest trust level and includes identity control points like domain controllers, identity providers, and PAM systems. Tier 1 covers important infrastructure, such as servers, databases, and enterprise applications. Tier 2 covers user endpoints and routine support. The critical rule is separation. Lower tier credentials must never be used in a way that could reach higher tier systems. PAW design is not one size fits all. The right model depends on what the administrator can affect. Identity and domain controller work require the strongest isolation, because compromise there can control everything else. Server administration often belongs in a separate Tier 1 path, sometimes through controlled jump access. Endpoint and help desk work should use a different admin path, so routine support cannot reach identity or infrastructure privileges. Cloud, SaaS, and application administration should be tiered by impact. The more critical the platform, the stronger the PAW controls. A PAW is one control point in a larger identity chain. The administrator should use a separate privileged account, not a daily use identity. Before access is granted, the device must prove it is compliant. The user must complete phishing-resistant MFA, and the requested role should be activated through PAM or PIM, ideally just in time. Conditional access then evaluates the full context: user, device, session, and policy. Only when each gate passes should the PAW connect to privileged systems, cloud resources, or admin portals. Hardening is what turns a dedicated workstation into a true PAW. The goal is to make the device predictable, tightly controlled, and difficult to misuse. Start with application control, so only approved admin tools and trusted binaries can run. Apply security baselines for firewall, encryption, secure boot, endpoint protection, and operating system configuration. Remove anything that expands risk, including unused apps, services, scripting tools, and unnecessary local admin rights. Then patch aggressively across the OS, drivers, firmware, permitted browsers, and security agents. A PAW must stay locked down continuously, not only at build time. Network access should be just as controlled as the device itself. Treat the PAW as an administrative access corridor, not a general-purpose network endpoint. Traffic should be denied by default and opened only to approved destinations, such as PAM portals, jump hosts, identity services, cloud consoles, management APIs, and monitoring tools. Personal email, social sites, file sharing, and broad internet access should be blocked unless there is a documented and tightly controlled need. Host firewalls, segmentation, and privileged access zones enforce the path, while logging confirms the PAW is behaving as expected. Many endpoint compromises begin with ordinary user activity: email, broad web browsing, downloads, and unmanaged apps. A PAW reduces that exposure by making privileged work intentionally constrained. No personal email, no general browsing, no random installers or file sharing sites. Access is limited to trusted admin destinations, such as PAM portals, cloud consoles, internal tools, and approved documentation. When browsing is required, use isolation, hardened profiles, and allow lists. Also, restrict USB, clipboard, and file transfers. The goal is to remove common infection paths before privileged credentials are ever exposed. A PAW should be managed as a lifecycle, not treated as a one-time build. It starts with a trusted image, approved baselines, and automated configuration, so every device begins from a known secure state. Then it is enrolled into management, detection, logging, compliance, and inventory systems. During use, administrators follow clear rules for when the PAW is required, what actions are allowed, and what is prohibited. Ongoing maintenance keeps it healthy through monitoring, patching, and review. At retirement, remove trust, revoke certificates, wipe storage, and update asset records so no access remains behind. Because PAWs are used for privileged actions, monitoring must cover both the workstation and the behavior flowing through it. Collect endpoint signals, such as process starts, application control decisions, logons, and security agent health. Correlate those signals with PAM, identity, network, and SIM data to see which tools were used, which systems were touched, and whether the activity fits policy. Alerts should focus on meaningful risk: failed MFA, unusual destinations, bypass attempts, or unapproved tools. If a PAW is suspected of compromise, treat it as incident response critical. Isolate it, reset credentials, and preserve evidence quickly. Roll out PAWs as a controlled adoption program, not as a basic workstation refresh. Start with Tier 0, where compromise is most damaging: identity admins, PAM operators, and domain controller access. Pilot with a small group, validate workflows, then expand to servers, cloud platforms, applications, and finally endpoint administration. The biggest failures usually come from convenience exceptions: email or browsing on pause, mixed admin tiers, weak compliance checks, and undocumented bypasses. Track progress through adoption, privileged access coverage, blocked risky actions, and reduce standing admin exposure. Those metrics show whether security is improving without breaking operations. Privileged Access Workstations close a critical gap by protecting the endpoint administrators use for high-risk work. The core pattern is simple: dedicate, harden, isolate, and monitor. PAWs are strongest when combined with tiered administration, vaulting, MFA, session monitoring, and disciplined operations. Next, we apply the same control mindset to SSH keys, secrets management, and PAM governance.